Okay, S-series switch network loop troubleshooting. And we know that the network loop is very damaged to our network. So we design a lot of protocols and we use a lot of ways to prevent this problem. First, let's see some diagnosis tools. This tool is loop detect, ether loop, alarm only, this command. For this command, loop detection is enabled on chassis switch globally by default. But on a box switch, loop detection needs to be enabled in a VLAN. And after a loop detection is enabled in a VLAN, run this command, display loop detect ether loop VLAN 100 to view loop detection configuration. And this function is enabled on a chassis switch by default. So run the terminal debugging and the terminal monitor command if MAC address flapping occurs. So if the loop detect ether loop alarm only is enabled, we can see here are the alarm informations on the chassis switch. For this information, we can see here is the MAC address. Here is the VLAN ID and the MAC address entry is from this interface to this interface. So there could be a MAC flapping, and this is alarm information on a box switch. The MAC address and the MAC address flapping is between this port and this port, GE2123 and GE2122. And we need also to pay attention to the ports with high traffic volumes, because these ports may exist on the loop. So we can use this command, display interface brief, and to check the inbound traffic and outbound traffic utilization. Or we can check the CPU defense statistics. Use this command, display CPU defend statistics. And this command we can check the ARP request statistics. The number of dropped packets, here we can see the dropped package is larger than the number of passing packets. This problem may be caused by protocol packet storm. Okay. From the previous, this is about some display commands about their diagnosis tools. Next, let's go to how to quickly identify loop. So these are the procedures of how to quickly identify loops. First step, check whether traffic statistics are normal. Traffic statistics on an interface are abnormal, or a lot of packets are discarded by CPCAR. If yes, a loop may exist. If not, we need to go to the second step. The step 2, configure MAC flapping detection globally or in a VLAN. So does MAC address flapping occur repeatedly? If it yes, it means a loop may exist. If not, goes to step 3. Configure LDT loop detection. Configure loop detection in a VLAN or on a port. Then, is a loop detected? If yes, it may exist. If not, it means there is no layer 2 loop. Okay, so first, let's see step 1. Identify a loop according to traffic statistics on interfaces. Display interface, Ethernet, brief, then check the traffic statistics. If only one port has a large volume of outgoing traffic, a loop may occur on the single port. 2. If two ports on a device have a large volume of traffic, a loop may occur on the ports of the local device as shown in the preceding information. Here, 2 ports. And if one port has unidirectional traffic, a loop may occur on the devices connected to these ports. Here are 3 situations. And the packets discarded by CPCAR help you detect loops. In normal situation, it is impossible that a lot of ARP packets are discarded in a short period. So if ARP packets may be forwarded in a loop, the switch functioning as an aggregation gateway will discard the packet through CPCAR. As shown in the following information, a lot of ARP request packets are discarded, so a loop may occur. Here we can see the drop packets of ARP request is much larger than the path packets. There must be some problems. Step 2. Identify a loop according to continuous MAC address flapping. If broadcast suppression, single ring or semi-ring is configured on the port, a storm will never be generated. In this case, you can detect loops according to MAC address flapping. MAC address flapping necessarily happens when a layer 2 loop occurs. If a device keeps printing the following alarm information, a lap may occur between these 2 interfaces. Step 3. Identify a loop through LDT, loop detection. The loop on a single port can be detected through loop detection. So, from the previous, we have talked about LDT. For the chassis switch, LDT is enabled globally by default, but on box switch, this function needs to be enabled manually and in a VLAN. So here you can see loop detection enable VLAN 100. Then display loop detection. Check whether a loop occurs on an interface in the VLAN. And from here, the port where a loop occurs is displayed. And we need to know that LDT can detect the loops on single ports and shut down the ports by default. For configuration of LDT, see the configuration guide. So when we identify loops, now we need to recover loops. How to break loops quickly? Ethernet loops cause storms with a short period and degrade service quality. After you confirm that a loop occurs, perform the following operations to break the loop. First, delete the port from the VLAN where the loop occurs. Second, shut down the port. Third, remove the fiber from the port. So, how to analyze the loop cause? Generally, a loop may be caused by network topology changes. Therefore, check the recent changes on network topology. Check whether the loop is caused by network reconstruction or operations. If the loop is caused by network reconstruction, modify the physical connections. Check whether the loop is caused by recent configurations. Check whether the following commands have been executed. Here are several features. Port management. A new port joins in forwarding in a loop by executing undo shutdown. For example, this port by default, or we shut down it administratively. So someone use this command undo shutdown this port, then there may be a loop occurs. So the solution, we can shut down the port or enable a loop protection protocol. Next, STP. For STP, if BPDU is not enabled, then there may be a loop. The BPDU enable command must be executed on a port of a box switch so that the switch can process STP packets. But this command, BPDU enable, has already been disabled by default in V1R6 and the later versions. Next command is BPDU bridge is enabled. So this command configures the switch to transparently transmit STP packets. So the STP packets are not sent to the CPU of the switch, and STP doesn't work. So we need to cancel the configuration. Use command undo BPDU bridge enable. Next feature is RRPP. RRPP is not enabled globally. So it means the switch does not calculate the port to be blocked. So we need to run this command RRPP enable. Here is a typical scenario. Loop on the local device. Loop on the local device. The prerequisite is STP or LDT is not configured on the switch. These two things are not configured on the switch. So the symptom is the incoming and outgoing traffic volume on the port increases continuously. The cause may be a loop occurs on the port or link. So the solution, this fault is caused by incorrect connections of fibers or network cables. So we need to remove the fibers or network cables for this one. And next, typical scenario is loop on the downstream device. And the switch 1, switch 2. Here there is a loop on the downstream device. The prerequisite is also STP or LDD is not configured on the devices, and no loop occurs on the local device. So the symptom is the incoming and outgoing traffic volume on the port increases continuously. So a loop occurs on the downstream port or link. And let's see the solution. First, find out the link where a loop occurs. Find out this on the downstream devices, hop by hop. So we need to check each port that has abnormal traffic volume. Then there are two types of loops caused by link. The loop on a single port and the loop between two ports on a device. These loops are caused by incorrect connections of fibers or network cables. So remove the fibers or network cables. For this one is network loop. The yellow one means the port that should be blocked. The red one, the port actually blocked. And the prerequisites are STP, RPP, or any protection loop protocol are not running on the device. The symptom is after a loop occurs, network convergence is normal. However, after a period, network convergence fails or routes keep flapping. The cause may be protocol packets cannot be forwarded on the ring network, and routes flapping occurs. So the solution could be, first, check error packets on each port on the ring. If error packets exist, replace the link or optical fiber or optical module. Second, check whether traffic suppression has been configured on each port on the ring. If traffic suppression has been configured, modify the configuration. Third, check network traffic on each port on the ring. The traffic, we need to check it on the ring. If there are packets discarded due to QoS on a port, then there may be some problems caused by QoS. Then we need to configure QoS. For this typical scenario, a loop caused by abnormal packet forwarding. Here is the port actually blocked. And the prerequisite is that layer 2 network convergence is normal and the port blocking instruction can be delivered. Symptom is MAC address flapping frequently occurs on switch 3. On this switch, a loop may occur. So the cause may be the layer 2 edge devices such as STBs, or of some vendors cannot process packets and they directly send the packets back. First, this switch sends the packet to this device, and some device they cannot process these packets, so they will send the packets back to the switch. Then this may cause the loop. So the solution is to replace the layer 2 edge devices, to replace these devices. Okay, so let's see network optimization. 1. Configure the loop prevention protocol. If the loop is caused by a physical loop, configure the loop prevention protocol. Commonly used loop prevention protocols include STP, RSTP, MSTP, RRPP, and SEP. 2. Improve link quality and reliability. If the loop is caused by poor physical link quality, protocol packets are discarded due to congestion. Check the link and replace the fibers or optical modules. If protocol packets are discarded due to insufficient bandwidth, increase bandwidth, or configure link aggregation. 3. Configure broadcast suppression to improve network robustness. To prevent repeated loop generations, configure broadcast suppression for the ports on the loop. Based on experience data, 1% broadcast suppression can prevent broadcast storms. 4. Configure QoS to ensure that protocol packets are forwarded first. 5. Optimize network design to improve network reliability. For a complex network, measures can be taken for each layer. Properly plan the access layer and aggregation layer. When a layer contains many devices, allocate the devices into different domains, logically and geographically. Okay, this lecture